Hi, welcome to DonskyTech. In this video, I am going to show you how to create your own REST or Representational State Transfer server using Python, Flask, and MongoDB. If you have your Internet of Things projects and you would like to control it from your database, or you want to create a logger of your sensor readings, then knowing what is REST API server and how to create one is important. This video is part 3 of my MongoDB IoT tutorial series, where I would show you how to create your own REST API server that will interact with our MongoDB database using Python and Flask. This series will teach you how to integrate a database, particularly the MongoDB NoSQL database in your IoT projects. We will be using Arduino-based microcontrollers, Raspberry Pi single-board computers, and MicroPython devices. Are you excited? Then let's start exploring. Before we move further, let us discuss first what is an API. API is an application programming interface, and it allows two computers to communicate with each other. Let's say we have a backend system like a database with information that we wanted to share to other users. It is not a good practice to let all users access your data directly and do dangerous things on your data. Imagine a scenario in a hospital management system wherein all people inside can access all the patient information. So, what do we do to add a security layer? We can introduce the concept of an API server that exposes a certain rules on how to access the data and add authorization on who can access it. The users of our system would begin interacting with our API server through a set of rules that we expose called an API. So, why do we need to set up our own API server if we want to interface with a database using our Arduino, Raspberry Pi, and MicroPython code? Aside from the security issues in the earlier slide, microcontrollers tends to have small memory footprint that connecting to a database would cause out-of-memory errors. Also, there is no driver that will allow you to connect to the database directly. For example, Arduino does not have any native drivers to connect directly to the MongoDB database. There is, however, a C or C++ driver that you can adopt, but that requires specific programming knowledge. So, what should we do? The quick solution is to create an API server that will communicate with our MongoDB database. The API server will act as our interface to the database, and if we would like our microcontrollers to communicate with the database, then we will talk to the API server. You can program the API server in the language of your choice, as there are many drivers available in different languages. In this post, we will program our API server in Python programming language. I hope you now appreciate and understand how important an API server role is in the whole architecture. Let us now discuss further what is meant by a REST API server and the REST topic itself. REST is an acronym for Representational State Transfer. It is actually a software architecture style that governs how a client and a server exchanges message over a network. Oftentimes, when you hear the word REST, it refers to a REST web service, which discusses how data can be accessed through public-facing web URL. You'll see later how the public-facing web URL are done. So, REST follows the client and the server topology, where there is a server and a client. Both of them are decoupled from each other, and they communicate through the internet. The clients and the server could be programmed in the different programming language, as they are independent from each other. They understand each other because they follow the REST API protocol. Usually, the client sends an HTTP request, and then the request is processed by the server, and it will respond with an appropriate HTTP response. As you can see, there is an HTTP request and an HTTP response whenever you're using the REST web service. So, a sample REST API server that is popular is the GitHub REST endpoint. The URL like this. It's a public-facing URL called a REST endpoint. When you type in the following URL in your browser, then you would be able to see the following messages displayed on your browser. If you do this exercise, then you are now interfacing with a REST client-server architecture. Your browser, where you type the GitHub URL, acts as the client, and the GitHub server acts as the server. If you open the developer tools in Chrome, you will see the following information such as the HTTP method, the HTTP URL or endpoint, the status, HTTP status, and the content type being displayed. So, what are these terms? We will discuss this in succeeding slides. REST architecture uses HTTP methods to manipulate server resources. When we say a resource refers to information that can be manipulated by the client. For example, if we are running a library system, then one resource could be a book. Or if we are running a car dealership business, then it could be a car. An HTTP request is initiated by the client and it is assigned a specific HTTP method. This table shows the common HTTP methods used to manipulate the server resource. As you can see, when you say get, it means you are getting an existing resource. When you send a post, then it means that you want to create a new resource. Similarly, the put, patch, and delete are used for updating and deleting resources. It is important to understand that the server checks the HTTP methods for every request coming in and respond accordingly. So, what are REST API endpoints? REST API server usually expose URLs to the clients so that they can manipulate the server resources. If we go back to our library systems and we are manipulating a book resource, then this table will show the different endpoints that you can send to the server. So for example, to get a list of books, we send an HTTP GET and the endpoint is /books, which means that if we pass an HTTP request with the GET method and the endpoint is /books, we will be able to get a list of books. However, if we are querying, for example, a specific ISBN number for a particular book, then we need to pass an HTTP GET with the following endpoint wherein anything after the question mark is considered as query parameters. So, as you can see in here, when you send an HTTP request at this API endpoint, you will get a specific book by ISBN number. Same also with the other HTTP method, like for example, for the delete, when you pass in the delete method with this API endpoint and you pass in the ID of the book, then it means you are deleting a book. You will see this in action later in the test application that we will develop. So, what are HTTP status code? When an HTTP request comes in from the client, then an appropriate HTTP response is created by the REST API server. It tells the client about the result of the processing, and this is largely based on the HTTP status codes. So for example, in the category, whenever the value starts with 2 or 200, 201, it means it is successful. If it's 3, it means redirection. For 4 or 400, it means a client error. And for 5, it means something bad happened at the server. So for example, if we are creating a book and we receive a response of HTTP 200, then it means that the book was created successfully. So, are you lost? If you are new to these topics, then I know you might be overwhelmed, and you should be. This is where an example project would help you understand what I am saying. So, have a little bit of patience and let's just move on with the tutorial. So, in this sample IoT project, we are going to keep track of the sensors that we are going to attach to our system. The data for each sensors is stored in our MongoDB database. In a future project, I will show you how easy it is to control your sensors from your database using your Arduino, Raspberry Pi, and MicroPython devices. As you can see from this image, you would see that these are the information for each sensor. For example, for our LED, we assigned a specific ID of LED underscore 1, and we have a description of which is our LED, the location where we place the sensor, and we can enable it by setting the value to true or false, and the value can be set as either on or off. We also have other temperature sensor here like the DHT22, wherein we could get the value of the current reading such as the temperature and humidity. So, before we could store or retrieve data from our MongoDB database, we will need to develop our REST API server to manipulate the data that is coming from our database. And we will use the Python programming language in here. The Python REST API server will provide public URLs for us to execute CRUD operations or the create, read, update, delete on our MongoDB database. We will be using Python, the Flask micro web framework, and the PyMongo libraries in connecting with our MongoDB database. So this image shows the different REST API endpoints that we are going to create on our Python code. For example, when we send a GET with an API endpoint of API sensors, then we should get all the sensors. Same also with the GET, and we pass in the sensor ID, for example, LED1, then we will just get a specific sensor with the sensor ID. Same also with the pause, put, delete, which we will use to add, update, and delete. So you'll see this in the code later and how we can test out all of these HTTP endpoints. Why did I choose Python? Python is an easy language to pick up, especially with hardware guys. But even if it is simple, it is actually very powerful. I have carefully chosen this language as any IoT developers can easily understand or read programs that are written in Python compared to languages such as JavaScript. The MicroPython, which is an extension of the Python language, and is gaining traction in the microcontroller community. MicroPython code is almost the same as the code in the Python. So I am quite sure that the IoT developers would understand how to create their own Python program. So what is Flask? Flask actually is a micro web framework written in Python that is popular for web development across Python enthusiasts. In this particular project, we're going to use Flask as our REST API server. Beginners actually can easily pick up this library as it contains default configurations already that a beginner could override. For example, this is a sample program that would print hello world in your browser. By just creating this simple program and then saving it as app.py and then setting the route into the root, then you would see that you can print the hello world in your browser. So what is PyMongo? PyMongo is a library written by the MongoDB team as a thin wrapper for commands so that we could interact with the MongoDB database. Later, you would see how easy it is to use this library, especially when executing transaction on our database. Now, before we proceed, we need to review first some MongoDB CRUD operations before we could continue with the tutorial. If you are not familiar with MongoDB, the first two parts of this series will tell you what is MongoDB is all about. So as you can see, when you want to create, then you just execute the insert one functions and then pass in a JSON. The same also with the read. You just pass in the find and then just pass in the JSON that you wanted to find. Same also with the update. There is update one and then the delete one. By the way, a note to advanced Python users. The project that I have created here does not create or use any object document mapping. So only PyMongo queries was used. Also, I'm not using any RESTful libraries and we're only using the Flask routing and view handling. There is no authentication or authorization and there is no elaborate exception handling, but only the basic error handling. You can do all of this or research about how this is done, but since the tutorial series is more oriented toward IoT developer, so I intentionally leave these particular topics in this program. Now, so much for theory. Then we can now go into the actual development of the project. In the previous video, we created a people DB database and then we populate it with the people collection. Now, we're going to create a new database called the sensors DB and you're going to create a collection called sensors. If you are not familiar on how to do this, then review my episode 2 of this tutorial series. I'm still using the MongoDB Compass in interfacing with my MongoDB database cluster. So for now, there is no data that is inside our sensors collection and we can insert the data by clicking the Add Data button here and insert the document. Then we can create a test document that will contain our sensors like this one. So I have an LED and a 7 segment and there is a value element here which means that it should be on or off and the 7 segment has a count which is the value of the 7 segment is 0 to 9. So right now the current value is 2. And then I will try to insert the 2 documents into my sensors collection. And then when the 2 documents is created, then there is an assigned object ID which uniquely identifies this particular document. Now, as I have mentioned, we will try first executing the CRUD operations using the Mongo SH terminal here. I'm using the Mongo SH here and I am showing you a demo first because the Mongo library uses the exact functions that I'm going to show you here in this Mongo SH terminal. So for now, let's try to execute the CRUD operations. If you want to know what is the current database that is created or being used by the terminal, then you can type the word DB and then you would see that it is using the people DB, which is the database that we created earlier. If you want to show all the database, then just click show and then the DBS. Then you would notice that I have the sensors DB here. If you want to switch to the sensors DB, because that's where we wanted to insert to our collection, then you can type in use and then sensors DB. Oops. Sensors DB. So right now, I am switched to the sensors DB and if I click DB, then you would see that it is the variable DB is now pointing to the sensors DB. If you wanted to clear the Mongo SH terminal, just click console.clear. Now let's try inserting a new record into this database first. The command to execute is similar to like this. So as you can see, there is a db sensors that insert 1. Let's just change this value into LED underscore 2. And then let's type into second LED. And then initially turn this on. And then let's say this LED is in the kitchen. Okay, and then we click enter. So the value is DB, which is the current name of the database. The collection's name is sensor, and then the insert one is the function. And then if we click enter, then you would see that a new object ID was created. So let's see if it really was inserted. Let's click refresh. Now I have the LED2 inside my sensors collection. Once we have then we can console.clear and then let's first try to execute the read. So for the read, it's the same also. It's just db.sensor and then find, or you could actually execute find1, which will find just the first record. And then we are passing the sensor ID, since this is the sensor ID. So let's try the newly inserted, and then let's try LED2. So as you can see, there is a return value, which is the object ID here, and my LED2. If you wanted to update the value, so say for example, we wanted to turn off the value in this collection or document, by the way, And what we can do is to execute the update one. That's just console clear. And then what we can do is we set first which document we wanted to update. In this case in here, this is LED2. Let's copy the object ID and then let's paste it here. And then right now it is on, so we are going to turn it off. Okay, as you can see, there is a modified count which is 1. Right now, the value is still on. If we click the refresh, then we would see that it is off. Now, if we wanted to delete the value that we created earlier, then we just need to execute the db.sensor delete one. And then we copy also this one, the object ID, and then paste it here. As you can see, we have a deleted count of 1, which means that this value should now be deleted when we refresh our MongoDB database. Let's click refresh. So the value is now deleted. The reason why I showed you first the MongoDB CRUD operation, it's because the code that I'm going to show you is using the PyMongo library, which is actually a wrapper library to those commands. So this is the program that is our REST API server. So this program is available in my GitHub repository. So this is the program, the repository where it is located, and the steps on how to run it is also listed in here. So I am going to show you how to test our REST API server and explain how the code works. However, if you are one of the hardcore type of developers and you wanted to create the project from scratch, I got you covered also, because I documented the steps on how to create the project and how it works one by one. So for example, there is a document here, and you can find this step-by-step procedure in my blog post. However, for test purposes here or for demo purposes, what we will do is just run the application and then I will explain how it works. So let's try running first the application. So to run the application, we just need to type Flask run. So let's wait for the Flask to run. Okay, now it says that the development server is now running. So let's just wait for it to restart. Okay, once you see these messages, then it means that the Flask server is now running. If we go into our browser and then type in localhost and then 5000, you would notice that there is a resource not found. It's because I intentionally did not create a view that will respond to this particular root URL. So let's first go back into our REST endpoint. As you can see, the REST endpoint here contains the get, which is the API/sensors. If we go in here and then type in API and then sensors and then click enter, then you would notice that I have received a JSON document array actually that contains our LED and the values of our sensors inside our sensors collections. If I click the developer tools in here and then click Ctrl R and I type the sensors here, you would notice that the request URL goes to localhost 5000 API sensors, and it's using the request method get and the status code, which is 200, which means that it is successful. Okay, so right now I'm testing it using the browser, but actually in reality you can use two tools in testing your REST API server. The first tool is called the curl. Curl is actually a command that you can execute in your terminal. It is available in Linux and Mac OS, but for Windows, you need to install. I have installed the Git bash, which is the software for the Git for Windows, so that I can execute the curl command. Issue a GET request, then you just execute curl, and then type in the endpoint, which is curl HTTP localhost 5000 API sensors, and click enter. As you can see, you would still receive the same JSON array from your browser. So right now, we were able to get the value for our localhost 5000 API sensors. As per our REST API endpoints, it says that if we pass in a sensor ID in here, then we would get a value for a particular sensor ID. So let's try it. Sensor ID, and then we pass in LED underscore 1. Then, oops, there is an error. It should be sensor underscore ID LED 1. Sensor underscore ID. And you would see that there is only one value, which is this is our LED. If we type in the same command in the curl, oops, sorry, it should be curl, and then type in, then you would see that it is retrieving me the first value, which is LED 1. So there is another tool that I am using, which is what we call as the Postman, which is more of a graphical user interface. As you can see, this is the GET request, and what you can do is just create a request in here, and then type in the URL. So say for example this one, and then set the HTTP method such as get, post, or put. So in that case, since I have created also the get all sensor, if I type in get and then click the send, and you would see that is returning to me the list of 2 sensors that I have enrolled in my MongoDB database. Now, if I type in the get sensor ID and then I specifically pass in sensor ID and LED 1, then you would see that I am only receiving the LED 1 document. So basically, we are executing a REST API request to our REST API server. If we now go back into our document, and then let's see how does it work actually. It actually is just simple. So right now, you can just import all of the required packages, and then we have this load.env. This load.env basically load the values of our MongoDB connection string, which you should have also when you sign up for your Atlas database. Next, we created an application for a class name, and then we load the environment. And then this is the PyMongo. We created the client for the Mongo client. Then we pass in the name of our MongoDB Atlas. And then we specifically set the DB variable into the client. And then the name of the database is sensor underscore DB. Now, this is where it gets interesting. As you can see, I have a function here called getSensors. And inside the getSensors, I have created this decorator, which says that this decorator will respond to any HTTP GET. So the GET request will point to the parameters API /sensors /sensors. Same also with the GET, there is a post here, the delete, and the put. So as I have mentioned, all of the REST API endpoint maps to a specific HTTP method in here. Now, if we go into our getSensor function, what I'm doing here is that in the sensor ID, I am requesting for the sensor ID, and if this query parameter named sensor ID is present in the request, then we have a filter here. The filter actually just checks if the sensor ID is none, then we return the empty JSON. Else, we will add a string or a DICT or dictionary wherein we need to filter by sensor ID. As I have mentioned in the earlier exercise in the Mongo SH terminal, you can see that I am executing db.sensors find, and then I am passing the filter. Whatever the filter values in here is it's what we're going to query with our database. Next, we convert it into a Python list, and that same Python list is now should be returned to our user. As you can see, I have created a response object here, and the application type is JSON, and I have just used the dumps. Dumps is actually a function that will convert the return type of our MongoDB from a BSON object into a JSON object, and we set the status into 200. Now that the status is 200, then we return the response. So basically, that is how the HTTP GET works. Now, let's try creating an HTTP post in here. So for the HTTP post, I have created here in my Postman application. So I have set the value of the HTTP method to post, and I'm still using the API, which is API sensors. But right now, I need to pass in the raw value in the body. So this is the body tag, and we set the value into a JSON. As you can see, there is an LED in here, and then there is a value of our second LED. Then if we check our MongoDB Compass and refresh it, there's still no data in here, right? So what we can do right now is if we click send, and it says that the sensor was added successfully. If we go back into our MongoDB and click refresh, and you now have the value of a new document for our LED2. So if you want to execute the same command in a curl, so let's just clear in here. So for the curl, the command is similar to this one. So there is a curl. The X parameter is set to post, and then it's still API sensors, and the content type is JSON. The ID is LED2, and if we click enter here, then it will create a new record. So let's try this one. I'm just going to delete it first. So it's now deleted. Now if we execute using curl, and you would see that the sensor was added successfully. If we try the refresh, then you would notice that I have a new record called LED2. If we go back into our project and we go into the app post, then we have here a method called addSensor, and we have decorated it with the app.post, and then the parameter is still API sensors. What we're doing is just we get the request from the HTTP request and then set this into JSON. And as you can see, I'm calling the db.sensors insert1. And upon calling the db.sensors insert1, I'm just going to return a message called sensors added successfully with a status code of 200. So that's basically how simple it is to create your own REST API server to create a new record in your MongoDB database. Now, let's go first into the update before we execute the delete. So for the update scenario, so I have here the update scenario here. And what we can do is that we just first need to copy the object ID in here. And as you can see from our code, there is a value here called ID, which means that this is a dynamic value, which is API sensors, and this dynamic value, which gets assigned to this variable ID. So what we need to do is to click this one, and then place the ID that we have copied from our new inserted records. And then we need to pass in the body also, and then set it to row and the JSON. Now the sensor ID is 2. And What we can do is we're going to toggle the value from off to on. And then let's just copy this one. Let's retain it to this is our second LED. And then it is located inside the garage. Then we click send. So what I am expecting is that this value, which is off, should be turned on. That's right. As you can see, it says sensors updated successfully. Let's try refreshing. As you can see, the value is now on, which means that it was successful in updating our records in our MongoDB database. Now for the code, let's check this one. It's almost similar to the plug sensor. The only difference is that instead of insert 1, we're using the update 1. So for the update 1, we need to set the value of the object ID, which is the value of the document that we wanted to update, and we set whatever the value that we sent from our HTTP request in here. Now, when everything is okay, we send in a sensor update successfully, and everything should be received by our users. Now, let's discuss the delete sensor. For the delete sensor, all we have to do is follow also the same structure. So instead of passing, I'm using the delete. So the HTTP is now using delete in here. So we need to copy the MongoDB database. And then we paste it in here. Okay. Now, the record is still here. Refresh. And if we execute the delete command, then we click send, a message would be received that sensors were deleted successfully. So, as you can see, if we go back into our program, which is the app.py, then you would see that the only difference here is that the command that I'm calling is delete 1, and I'm passing the object ID, which is coming from our request, and the HTTP method is delete. So that's how easy it is to create or develop your own project and have your REST API server communicate with our MongoDB database. I have here several functions also, which is I have just used for error handling. The reason that you need error handling is because, for example, if we try to add a new sensor, so for example, this is a new sensor and we deleted the request. If we send the functions here, then you would see that I have an error code here which says that this is a bad request because I'm trying to add, which is a post, a new record, but I did not specifically pass in the JSON request. So if you wanted to create a new record to our database, then you need to pass in the complete JSON request. So this is actually how easy it is to create a new REST API server by just using one file, which is the app.py in Python. So if ever there is a questions that you don't understand, then I highly suggest that you read the documentation that I have created in here, because this documentation is fairly detailed, and if ever you have any questions or anything that is not you cannot understand by yourself, then create a comment in my YouTube video. So basically that's all for this project, and it's quite a long one, but I hope that you have learned something from this particular video. Until the next video in this series, I hope you learned something. Happy exploring!